differentiations using first principle. Okay, the rule is f dash x is same as limits, okay, h approach to 0, f of x plus h minus f of x all over h. Okay, that's the rule. So let's say fx equal, let's say 3x. Okay, I want to differentiate this using first principle. So this is the rule, okay, up here. So first of all, I'm gonna find f of x plus h first. Now what that means is every time you see x, you replay with this x plus h. Okay, so this means that 3 lots of x plus h. So if I expand this out, give me 3x plus 3h. Okay, and then I'm gonna find the limit. Okay, limit h approach to 0. Okay, f of x plus h minus fx all over h is the same as limit h approach to 0. Okay, 3x plus 3h minus fx, which is 3x, all over h. Okay, then this one cancel out, then you're left with 3h over h, so which is same as 3. Okay, so that means it's same as limit h approach to 0, 3. So your answer is 3. So therefore f dash x is equal to 3. Okay, so you get that. Okay, let's move on. Next one. Let's say f of x is x squared. So I want you to differentiate this using first principle. Okay, so if you can do ahead of me, please do it. Otherwise, just watch. Okay, so let's say first of all, I need to find f of x plus h first. Correct? We just do one step at a time. Now I'm gonna write the rule here so you can see how I do it. Okay, just make it a bit smaller so I can fit this here. So f dash x equal limit, okay, h approach to 0, f of x plus h minus fx all over h. Okay, that's the rule. All right, now I just do f of x plus h first. Again, every time you see this x here, replace with this. That's all. All right, so that means become x plus h all power of 2. Then if I expand this out, I will get x squared, x times h is xh, and then you double, so 2xh, and then plus h squared. Okay, now I just write the rule f dash x is same as limit, okay, h approach to 0, f of x plus h, okay, minus fx all over h. So I just substitute it in, so that become limit h approach to 0, right? So f of x plus h, f of h plus h is this. Okay, so I just write it down, so that become x squared plus 2xh plus h squared minus fx. Fx is this. Okay, so I just minus x squared, then all over h. Now x squared minus x squared gone. Okay, then I'm just going to write this down, same as limit h approach to 0. Now because left with 2xh plus h squared, I take the common factor out. Common factor is h, so I take the h out. That gives me 2h plus h all over h. See, so I just write the h a bit properly, so over h. Then what I do, I cancel out, so that become limit, okay, h approach to 0, okay, 2x plus h. Now h approach to 0, that means this become approach to 0, so therefore your answer f dash x, okay, is equal to 2x. Alright, so you get that? Now, let's do a challenging one, okay, a little bit harder, okay, so let's say fx, equal to x power 3, okay, so let's say we're going to differentiate this, okay, using first principle. So let's say f of x plus h first. We just work out one step at a time. So give me 2x plus h all power 3. Now, I'm going to expand this, of course. So now a power 3 is same as a and times by a squared. I shouldn't have to put bracket, no need to. So just times by a squared, correct? So I just rewrite like that. So h and then x plus h squared. Then that become 2x plus h. I just expand this out. It gives me x squared plus 2h plus h squared. Then I'm going to expand further. So that gives me x power 3 plus 2x squared h plus, because I expand like this, and then the next one is h squared. Now I'm going to do h times x squared is x squared h, and this time that add 2hx squared and then plus h power 3. Okay, so that's what I get. Then I'm gonna simplify first. So this x squared and x squared simplify, and this one and their like term I simplify. So I will get 2. Okay, so x power 3 add 3x squared h add 3x h squared add h power 3. Then if I expand this out, it gives me 2x cubed. I better write the 3 properly. So that become 3 add 6x squared h add 6h h squared add 2h power 3. Okay, now I'm gonna follow the rule. Okay, so first of all, because otherwise it can be very long and complicated, so I just do this first. I'm gonna do f of x plus h, okay, minus f of x first, and then over h first. Okay, so now what that is, I just minus it, so which means this here, okay, this function here, and take away 2x power 3. Okay, so now 2x power 3, so if I take 2x power 3, this is disappear. Alright, so now you only left with 6x squared h at 6h h squared at 2h power 3 and over h. Right, now I can just take the common factor out. The common factor is h x squared plus 6xh plus 2h squared all over h. So that will be cancelled out. That will leave with 6x squared plus 6xh plus 2h squared. Excuse me. Alright, that's what I get. Now, okay, the rule f dash x is equal to limit h approach to 0 f of x plus h minus f of x all over h, which is same as limit h approach to 0 6x squared plus 6xh plus 2h squared. So if h approach to 0, okay, so this means that this approach to 0, because h approach to 0 becomes 0, and this is approach to 0. So your answer is 6x squared. So therefore, f dash x is equal to 6x squared. Okay, now let's do last one. Okay, this one is slightly different, okay, because this one is involving sets. So let's say fx, okay, is equal to square root of x. Now I want to differentiate this using first principle. Now, a bit tricky. Okay, so what we do, okay, we just follow the rule first. So you got fx plus h first. So this will give me x plus h, all right, square root. Now, I'm just go f of x plus h minus fx. So which is equal to x plus h square root minus fx, which is square root of x. Right? Now, what I do next is, because I want to get rid of the h, the x square root. So therefore, what I do, okay, I times by the conjugate, okay, and then divide. So let's say if I times by, okay, square root of x plus h plus root x, I must divide it by, okay, x plus h, okay, plus square root of x as well. Okay, so that's what I'm trying to do. Now, if I do that, of course, this is a bracket. This would give me, okay, this would give me difference of two squares. See this one and this one, you become what? Become x plus h. That's right. Okay, and then minus x, because difference of two squares. So this square, okay, this square minus this square. So that's what you get. Then over x plus h square root, of course, and then minus, plus square root of x. Okay, so this one cancel out. So what I get is f of x plus h minus fx, which is equal to h over x plus h square root plus square root of x. See? Now I've divided by h. See? That means I just divide by h is times 1 over h if you like. So this cancel out. Can you see that? Yes? So now it will give me 1 over x plus h square root plus square root of x. F dash x is equal to limit h approach to 0 f of x plus h minus f of x all over h, which is equal to limit h approach to 0. Now this one here is that, okay, which is theta. So which is the same as 1 over square root of x plus h plus x square root. Now, when h approach to 0, this one becomes 0. Okay? So now, this will give me what? 1 over square root of x plus square root of x. So 2 square root of x. Okay, so now therefore, okay, f dash x is equal to 1 over 2 root x. Thank you so much for watching my video.